Today we shall study the Jacobi symbol. We have already studied the Legendre symbol or the Legendre symbol A by P, where P is an odd prime. If P is an odd prime, the Legendre symbol A by P is defined as 1 if A is a quadratic residue or P. Here A is assumed to be not divisible by P. Minus 1 if A is a quadratic non-residue or P. And 0 if P divides A. Then we have seen important properties of the Legendre symbol, like A by P is congruent to A raised to P minus 1 by 2 mod P. We have seen that there is a multiplicative property, AB by P equal to A by P into B by P, like a homomorphism. We have seen some other properties, like if P does not divide A square by P is equal to 1. Also, a square B by P is equal to B by P. We can forget about this square provided P does not divide A. Then we have properties like minus 1 by P equal to minus 1 raised to P minus 1 by 2, 2 by P equal to minus 1 raised to P square minus 1 by 8, and the quadratic reciprocity law states that P and Q times with P not equal to Q, these are odd primes, then P by Q into Q by P equal to minus 1 raised to P minus 1 by 2 into Q minus 1 by 2. This is the quadratic reciprocity law. So, when we do calculations and find out the Legendre symbol, all these laws are useful. However, if we have A to be a composite number, many times we have to factorize it for the use of the quadratic reciprocity law. This factorization is complicated, especially if the numbers are large. And then the Jacobi symbol is very much useful in the calculation of the Legendre symbol. So let us see how this calculation can be done using the Jacobi symbol. The definition of the Jacobi symbol is like this. Jacobi symbol. We define the Jacobi symbol in terms of the Legendre symbol, and Jacobi symbol is defined when we have an odd number Q bigger than 1. That will replace the prime P. So, Jacobi symbol P by Q. P is an integer, Q odd integer bigger than 1. Is defined as follows. Write Q as a product of primes. Right? Q equal to P1, P2, PR. These Pi are primes not necessarily distinct. Pi primes, like P1 square, you write P1 into P1, not necessarily distinct. Then P by Q is equal to, this is the definition, it may be good to denote this by Q1, Q2, UR for convenience. UI primes not necessarily distinct. It is P by Q1, etc., P by QR. Where these P by Q1, P by Q2, P by QR, they are usual legendre symbols. Where P by Qi is the legendre symbol. Or 1 less than equal to I less than equal to R. So you write Q as a product of primes and using the legendre symbols P by Q1, etc., P by QR, you define the Jacobi symbol. Obviously, if Q itself is a prime number, then P by Q will be the legendre symbol only. Q itself is a prime number, then the legendre symbol and the Jacobi symbol coincide. So if Q is a prime number, this is odd, is an odd prime number, then P by Q, Jacobi symbol, is equal to P by Q, legendre symbol. They coincide in this denominator is a prime number. We can calculate this Jacobi symbol. For example, what is 2 by 15? Here this is an odd number bigger than 1. It is not a prime number. We have to factorize this. 2 by 3 into 2 by 5. What is 2 by 3? It's minus 1. This is legendre symbol. 2 is not a square, mod 3. 2 is not a square, mod 5 also. This is minus 1, this is plus 1. The value of the Jacobi symbol comes out to be 1. So here, is 2 a quadratic residue mod 15? 2 by 15 Jacobi symbol is 1. Is 2 a quadratic residue mod 15? Mod 15. You may think that because this symbol is 1, 2 is a quadratic residue mod 15. But that is not so. Why? Because the answer is no. 2 is a quadratic residue mod 15 means x square congruent to 2 mod 15 is solvable. 2 is a square of something mod 15. But if 2 is a square of something mod 15, then it is a square of something, that thing mod 3 also, 5 also. And that is not the case. Now, square congruent to 2 mod 15 is not solvable, as square congruent to 2 mod 3 is not solvable. It is a factor of 15. Because this is not solvable, this cannot be solvable. Any solution, suppose a square congruent to 2 mod 15, a square will be congruent to 2 mod 3 also. That is not possible. So sometimes this Jacobi symbol may give you some misleading result. So this is, Jacobi symbol is a generalization of the Legendre symbol, but the basic property is not satisfied. So note that P by Q, this is Jacobi symbol, equal to 1 may not imply that P is quadratic residue modulo Q. This is clear from the example. We can think of an example like this. 2 by 25, very easy example. 2 is, what is 2 by 25? It is 2 by 5 into 2 by 5. And this is square of something, plus or minus 1, whatever it is. This is this one. So it is square of this quantity. But 2 is not a quadratic residue mod 25 because 2 is not a quadratic residue mod 5. 2 is not a quadratic residue mod 25 because it is not a quadratic residue mod. So we can easily construct examples which tell you that property of the Legendre symbol, basic defining property, that A by P equal to 1 means A is a quadratic residue mod P. Such a thing is not valid for the Jacobi symbol. However, Jacobi symbol has many properties which are similar to the properties of the Legendre symbol. So let us see these one by one. So properties of the Jacobi symbol. One, P by Q equal to 0 if it is assumed that Q is odd bigger than 1, okay? That is bigger than, that's assumed. P is some integer. P by Q equal to 0 if GCD of P and Q is bigger than 1. And P by Q equal to plus or minus 1 otherwise. This follows from the factorization of Q, the definition of the Jacobi symbol. Suppose P by Q, proof of this, suppose PQ is bigger than 1, then if you write Q equal to Q1, Q2, QR, then sum Qi divides P. Because GCD is bigger than 1. Therefore, P by Qi, what is the value of this legendary symbol? Qi divides P, so P by Qi is 0. Now you calculate P by Q, therefore P by Q is equal to P by Q1, etc. P by QR. This will also be 0 because one of the terms is 0. This argument actually is when P is non-zero. If P itself is 0, then anyway this P by Q is 0. If PQ is equal to 1, each PY is equal to plus or minus 1. So, P by Q is plus or minus 1. That proves this property. Second property is that Q1, Q2 are odd bigger than 1, P by Q1, Q2 equal to P by Q1 into P by Q2. Multiplicative property for the denominator. That is consequence of the definition, right? Q1 equal to small q1, small q2, small qr, q2 equal to q1 dash, q2 dash, etc. qs dash. So these are primes, these are also primes. So qi dash, qi and qj dash being primes. They are all odd primes. Therefore, what is Q1, Q2? Q1, Q2 is the product of the primes Q1, Q2, QR, Q1 dash, etc. QS dash. Then use the definition. What is P by Q1 into P by Q2? The factors of Q1 are small q1, small q2, small qr. It is P by Q1, P by Q2, etc. P by qr. Then you write P by Q1 dash, etc. P by QS dash. This whole thing is product of Q1, Q2, QR, Q1 dash, QS dash is what? This product is Q1, Q2. Therefore, this quantity is Jacobi symbol P by Q1, Q2. This is an easy consequence of the definition of the Jacobi symbol. Similarly, you have the multiplicative property for the numerator. So, P1, P2 by Q equal to P1 by Q into P2 by Q. To prove this, we have to factorize this Q, use the definition, use the property of the Legendre symbol, similar property, because Jacobi symbol is defined in terms of Legendre symbol. So most of the properties of the Jacobi symbol are derived using the corresponding properties of the Legendre symbol. So proof of this property, write Q equal to, so Q is odd, bigger than 1, right? Q equal to Q1, Q2, QR. Qi primes. They may or may not be distinct. Therefore, P1, P2 by Q is equal to P1, P2 by Q1, etc. P1, P2 by QR. But what is P1, P2 by Q1? This is Legendre symbol. Q1 is an odd prime. P1, P2 by Q1 is equal to P1 by Q1 into P2 by Q1. Similarly, you can write for all other terms. So this is equal to P1 by Q1 into P2 by Q1, etc. Finally, P1 by QR into P2 by QR. Now we take these terms together, corresponding to P1, all terms we take together, and take these terms corresponding to P2 together. So rearrange. So this is P1 by Q1, P1 by Q2, etc. P1 by QR. So all terms corresponding to P1 we have taken together, and then take P2 by Q1, etc. P2 by QR. What does this give? This thing is P1 by Q, and this is P2 by Q. This is the definition of Jacobi symbol, and this is as a property P1 by Q1, P2 by Q1. This is the property of the Legendre symbol. That's what we have used. So if you want, you can mention that by Legendre symbol property. This thing. Then rearrange and get the result. So we have multiplicative property for the numerator of the Jacobi symbol also. Next, if PQ equal to 1 and PQ odd bigger than 1, then square by Q equal to P by Q square equal to 1. This is an easy property. Use the multiplicativity for the numerator and denominator. Proof of this is square by Q equal to P by Q into P by Q. That is equal to P by Q, Legendre symbol, square of that. What is P by Q? That P and Q are co-prime. They don't have a prime in common. Means the value of P by Q is plus or minus 1. But PQ equal to 1. So P by Q, Legendre symbol, is plus or minus 1. And its square is plus 1. So square by Q, Legendre symbol, is 1. In a similar manner, P by Q square we can write as P by Q into P by Q. And this is square of P by Q. P by Q is plus minus 1, so this is equal to 1. In a similar manner, this is 1. That proves this property. If P dash Q dash GCD is 1, then P dash square upon Q dash square, we are assuming that Q and Q dash, they are odd. This quantity is equal to what? P upon Q. Can be obtained by using the property 4. The proof of this is P dash square on Q dash square is equal to P dash square on Q into P dash square upon Q dash square. Numerator is kept as the same. In denominator, you just split. So something upon Q dash square. That something is coprime to the denominator. See here, is equal to 1 provided P and Q are coprime. Okay. So this thing is coprime to Q dash. So say now P dash square is coprime to Q dash. That is, so P dash square on Q dash square is equal to 1. This is about this term. About the first term, again you split that for the numerator. So, P dash square upon Q is equal to P upon Q into P dash square upon Q. What is P dash square upon Q? P dash and Q are coprime. Therefore, this is 1. So, it is P upon Q. This square here. So, this is equal to P upon Q means P dash Q. GCD is 1. And you have square here. So, this is 1. So, this is P upon Q. And that shows that P dash square upon Q dash square is equal to P upon Q Jacobi symbol. Thus, means we can forget about the squares. When you evaluate the Jacobi symbol, you can forget about the squares. Only condition is that these should be coprime. These are very basic properties. We shall have additional properties. One more property let me state. If P congruent to P dash mod Q, okay, Q odd bigger than 1 is there, P congruent to P dash mod Q, then what is P by Q? It should be equal to P dash by Q. Similar to the property of the Legendre symbol. And it can be derived from the property of the Legendre symbol. Proof is Q equal to, as usual, Q1, Q2, QR, QI primes. Therefore, what is P upon Q? It is P upon Q1, etc., P upon QR. But P is congruent to P dash mod Q. Take any divisor Qi of capital Q. Therefore, P congruent to P dash mod Qi also 1 less than equal to I less than equal to R. Any divisor Qi of capital Q, we get this property. And therefore, by the property of the Legendre symbol, P upon Qi equal to P dash upon Qi by property of Legendre symbol. P by Qi equal to P dash by Qi. If you use this property in this, P by Q will be equal to P by, so P dash by Q1, etc., P dash by QR. Therefore, P by Q equal to P dash by Q1, etc., P dash by QR. So that is the same as P dash by Q by the definition of the Jacobi symbol. as a definition of the Jacobi symbol. So these are very basic elementary properties of the Jacobi symbol. And from these properties, we will derive non-trivial properties of the Jacobi symbol. These non-trivial properties are similar to the corresponding properties of the Legendre symbol. These give you what is the value of minus 1 by capital Q. What is the value of 2 by capital Q? What is the value of capital P upon capital Q multiplied by capital Q upon capital P? You will see that these are very similar, the corresponding properties of the Legendre symbol. Let Q and you can also assume P be odd bigger than 1. Minus 1 by Q equal to minus 1 raised to Q minus 1 by 2. And 2 by Q equal to is 2 by Q, similar to the property of the Legendre symbol. So it is minus 1 raised to Q square minus 1 by 8. And the third property is P by Q into Q by P. Here P and Q are not necessarily primes. They are odd numbers, odd positive integers greater than 1. Is equal to what? Minus 1 raised to P minus 1 by 2 into Q minus 1 by 2. The power is same. P minus 1, big P minus 1 by 2 into big Q minus 1 by 2. So this is easy to remember. You see that these properties are exactly like properties of Legendre symbol. Only thing is that the basic property of the Legendre symbol is not satisfied by the Jacobi symbol. That means A by capital Q is equal to 1. From that you cannot conclude A is quadratic residue mod Q. That is the only difficulty. We shall see how this Jacobi symbol is useful because of these properties. Also, as we have seen in the case of the Jacobi symbol, we don't have to calculate this Q minus 1 by 2, Q square minus 1 by 8 and this thing. We have already interpreted things in a different way. What is the interpretation of this thing? Minus 1 raised to Q minus 1 by 2. If Q is 1 mod 4, then Q minus 1 by 2 will be even. Minus 1 raised to that is plus 1. So we can say minus 1 by Q is equal to plus 1 if Q is congruent to 1 mod 4 and minus 1 if Q is congruent to 3 mod 4. Similarly, Q by Q is equal to plus 1 if, this is the condition, capital Q is congruent to 1 or 7 mod 8. If it is 3 or 5 mod 8, the value is minus 1. It is just a consequence of this formula minus 1 raised to Q square minus 1 by 8. Third thing, this also you can write in a simple manner, is that at least one of P and Q is congruent to 1 mod 4. Then what happens? Either P minus 1 by 2 is even or Q minus 1 by 2 is even. Product is even, minus 1 raised to even number is plus 1, so value is plus 1. And then P by Q will be equal to Q by P. Both are minus 1, means P minus 1 by 2, this minus 1 by 2 is odd, that means P congruent to 3 mod 4. P congruent to 3 mod 4 would give, this is odd, odd into odd, is odd, minus 1 raised to odd is minus. So if both P and Q are 3 mod 4, P by Q into Q by P is minus 1. That means P by Q and Q by P are opposite in sign. If one of them is plus 1, the other is minus 1. So that is the conclusion, which is similar to the conclusion for the Legendre symbol. So maybe I can write this for your reference. Plus minus 1 by P, let us say minus 1 by Q is equal to 1 if P congruent to this Q congruent to 1 mod 4, minus 1 if Q congruent to P mod 4. That is the interpretation. What about 2 by Q? Equal to 1 if Q congruent to 1 or 7 or 8. Minus 1 if Q is congruent to 3 or 5 or 8. What is the alternative formation? Is the third property. P by Q is equal to Q by P if at least one of P and Q is congruent to 1 mod 4. If P or Q means both can also be congruent to 1 mod 4, equal to minus Q by P if both PQ congruent to P mod 4. This way we can avoid calculation. So proof of this can be given using the corresponding property of the Legendre symbol. Like if you want to prove minus 1 by Q equal to minus 1 raised to Q minus 1 by 2, you use the corresponding property that if P is prime, odd prime, then minus 1 by P is equal to minus 1 raised to P minus 1 by 2. And similarly for the other things. Let us see how we do this one by one. So first one is minus 1 by Q equal to. So write first of all Q is a product of primes. That is the first step. Right? Q equal to Qi odd primes. They may or may not be distinct. Therefore, what is minus 1 by Q? Is minus 1 by Q1, etc. minus 1 by Qr. It is by the definition of the Jacobi symbol. But what are these minus 1 by Q1, minus 1 by Q2, minus 1 by Qr? We know the value of this Legendre symbol. These are all Legendre symbols. This is equal to minus 1 raised to Q1 minus 1 by 2, etc. minus 1 raised to Qr minus 1 by 2. So minus 1 raised to A into minus 1 raised to B into minus 1 raised to C, etc. This is the addition of the powers. This is minus 1 raised to summation Qi minus 1 by 2. This is not Legendre symbol, but it is just Q minus 1 by 2, I equal to 1 to R. What do you want to show now? You want to show that minus 1 by q is equal to minus 1 raised to capital Q minus 1 by 2. So that doesn't mean q minus 1 by 2 is equal to this quantity. What we want is, when are two powers of minus 1 equal? Minus 1 raised to a equal to minus 1 raised to b. When does that happen? That happens if both a and b are odd or both a and b are even. That's what should happen. So capital Q minus 1 by 2 should be the same parity as this, or it should be congruent to this quantity modulo 2. That is what you have to prove. To do that, we observe this simple fact. Observe that if A, B are odd, minus 1, B minus 1 are even, and AB minus 1, if you consider this quantity, is equal to A minus 1 into B minus 1 this is plus A minus 1 plus B minus 1. So AB is here, A into minus 1, so minus A plus A, that gets cancelled. Similarly, minus B plus B gets cancelled. And we have minus 1 here. Here we have plus 1, minus 1, minus 1. So we get minus 4 also adjusted. Now this quantity A minus 1 is even and B minus 1 is even. So this product is divisible by 4. We can say AB minus 1 is congruent to A minus 1 plus B minus 1 mod 4. So this whole congruence we can divide by 2, because AB is odd, AB minus 1 is even. This we can divide by 2, this can be divided by 2, this can be divided by 2, and this 4 also we divide by 2. So throughout we divide the congruence by 2. Therefore, AB minus 1 by 2 is congruent to A minus 1 by 2 plus B minus 1 by 2 mod 2. Mod 2. Throughout we are dividing by 2. This we can extend. Like suppose you have A and B as Q1 and Q2. So Q1 Q2 minus 1 by 2 is congruent to Q1 minus 1 by 2 plus Q2 minus 1 by 2. If you have 3 primes or even odd numbers, Q1, Q2, Q3, Q1, Q2, Q3 minus 1 by 2, first you can write Q1, Q2 minus 1 by 2 plus Q3 minus 1 by 2. Not. In that Q1, Q2 also you can split further. Q1 minus 1 by 2 plus Q2 minus 1 by 2. So you can have any number, say Q1, Q2, QR minus 1 by 2. Therefore, continuing, we get result of the following type: Q1, Q2, QR minus 1 by 2 congruent to Q1 minus 1 by 2 plus Q2 minus 1 by 2 plus QR minus 1 by 2 mod 2. This means that minus 1 by Q, which had come out to be minus 1 raised to summation Qi minus 1 by 2 I equal to 1 to R, which is equal to, oh, this quantity is here, which is congruent to this quantity. So it is minus 1 raised to Q1, Q2, QR minus 1 divided by 2. Because these two are congruent mod 2. What is Q1, Q2, QR? Is the number Q, capital Q. So this is equal to minus 1 raised to Q minus 1 divided by 2. That's what we wanted to prove. This is a property of the Jacobi symbol which has been obtained by using the corresponding property of the Legendre symbol. Similarly, you consider 2 by Q. What is 2 by Q? Again, by definition, it is product of 2 by Qi equal to 1 to R. The definition of the Jacobi symbol. But now we already know the value of 2 by Qi because that is the Legendre symbol. 2 by Qi, Qi is odd prime, is minus 1 raised to Qi square minus 1 by 8. It is product of minus 1 raised to Qi square minus 1 by 8. Product is from I equal to 1 to R. Now this is the product. So minus 1 raised to sum of all such things is equal to minus 1 raised to summation Qi square minus 1 by 8 equal to 1 to R. This is the power of minus 1. What do you want to show now? It should be equal to minus 1 raised to capital Q square minus 1 by 8. Means this quantity and capital Q square minus 1 by 8, that quantity, they should be congruent to each other mod 2. This is the requirement. But that you can show in a similar manner. So let me do that. Now, a square b square minus 1. Similar to the previous equation, you write it as a square minus 1 into b square minus 1. Do adjustment to get this thing plus a square minus 1 plus b square minus 1. A square b square is here minus 1 and here we have plus 1 minus 1 minus 1, so that's also adjusted. And a square into minus 1 and plus a square gets cancelled. Minus b square plus b square gets cancelled. So this is an identity. And now observe that a and b are odd, then a square minus 1. What do you know about a square minus 1? Square of an odd number is congruent to 1 mod 8. A square minus 1 is divisible by 8. For a odd and b odd, a square minus 1, b square minus 1 are divisible by 8. Square of an odd number is congruent to 1 mod 8. Here this is divisible by 8, this is also divisible by 8. First of all, you can say that if you divide by 8, what happens? Let us see. A square b square minus 1 divided by 8 is equal to a square minus 1 by 8 into b square minus 1, just one of them you divide by 8, other you can keep it as it is. So let me write like this, plus a square minus 1 by 8 plus b square minus 1 by 8. So this is an integer because this is odd square minus 1 by 8, so it's an integer. This is an integer And this is divisible by 8. B square minus 1 is divisible by 8. So this quantity is divisible by 8. Means this is congruent to this plus this modulo 8. Therefore, a square b square minus 1 by 8 is congruent to mod 8. Actually, mod 8 is not required by us. It is sufficient for us to consider this mod 2. And so, square b square minus 1 by 8 is congruent to a square minus 1 by 8 plus mod 2. This much is enough for us. So, you can just replace this AB by Q1, Q2 or Q1, Q2, Q3 and so on. You can have a similar result. Therefore, continuing like this, Q1 square, Q2 square, etc. QR square minus 1 by 8. This we can write already as Q square minus 1 by 8. Q square minus 1 by 8 is this. Is congruent to summation Qi square minus 1 by 8 equal to into R. Modulo summation Qi square minus 1 by 8 mod. This gives us what is 2 by Q. It was already equal to minus 1 raised to summation I equal to 1 to R Q square minus 1 by 8. That is equal to minus 1 raised to Q square minus 1 by 8. Because Q square minus 1 by 8 is congruent to this sum modulo 2. That proves this result. We have proved that minus 1 by Q has formula like Legendre symbol is minus 1 raised to Q minus 1 by 2, and 2 by Q also has similar formula. Q by Q, capital Q, Q odd is equal to minus 1 raised to Q square minus 1 by 8. So next time we shall prove the reciprocity law, that is capital P by capital Q into capital Q by capital P, product of Jacobi symbols, is equal to minus 1 raised to capital P minus 1 by 2 into capital Q minus 1 by. Then we shall also see how the Jacobi symbol is useful in calculating the Legendre symbol.